Hi guys, this is me Rohan. I hope you all are doing absolutely fine, and I am here to present my project, an advanced home automation system that seamlessly merges with facial recognition, Telegram messaging, and relay control. This cutting-edge integration is designed to elevate your daily life with unparalleled convenience while also optimizing energy efficiency in your home or workplace. Now, let's talk about the key components of this project. So, we have 7 key components of this project. First is Python, which is the foundation for this system implementation and powers the face detection, Telegram integration, and control logic. Secondly, we have OpenCV, which captures and processes the video frames in real time and provides a visual interface with overlays for facial landmarks and rectangles. Third, we have DLEP, which ensures the accurate face detection and facial landmarks identification and tracks the user's presence and location. Then we have Telebot. Telebot facilitates integration with the Telegram bot API, manages user commands and responses, enabling remote control. Then we have Arduino, which acts as a central controller for the reader module, interprets Python commands, and controls electrical devices. Then we have 4-channel relay module, which serves as the interface between Arduino and electrical devices, enables remote control of multiple devices, enhancing convenience. Then we have webcam, which captures the video frames for the face detection, and it is one of the essential hardware components for real-time processing. Now, let's talk about the working of the project. We have divided into 7 parts so that it is easy to understand. First is the initialization part. So the system kicks off with an initialization process. The Python script are executed to set up web camera, establish communication with the Arduino microcontroller, and configure the Telegram for Telegram integration. Then we have, secondly, we have face detection and landmarks. Using the power of OpenCV and DLib, the system starts capturing the video frames from the webcam. Then OpenCV processes these frames in real time, identifying faces in the footage. Now, DLib comes into play to not only detect face accurately, but also pinpoint specific facial landmarks. Then we have user interface interaction with Telegram. As users, we have privilege to interact with the system through Telegram. By sending specific commands to our Telegram bot, we can control lights, appliances, and other electrical devices in our home or workspace. Then we have port polling thread. To ensure uninterrupted interactions and responsiveness, a separate thread handles Telegram bot polling in the background. This keeps the system alert and ready to respond to our command at any moment. Then we have relay control. The Arduino microcontroller serves as the brain behind the relay module. It interprets the command it receives from the Python via serial communication and takes appropriate action. Based on the user commands, the Arduino controls the relay module, effectively toggling the electrical devices on or off. Then display information. Throughout this process, OpenCV enriches our experience by overlaying key information on the video feed. This includes detail like number of faces detected, the user's location, and other vital system status information as well. Then we have exit condition. When it's time to conclude our interaction with the system, we have a graceful exit option. Simply press Q key and the Python script terminates and bringing the face detection and relay control process to the close. Now let's talk about how this Python code works. So first of all, we have imported the necessary libraries, which is CV2, which is OpenCV. This library is used for image processing, allowing the system to capture video frames from the webcam and manipulates them in real time. Then we have DLib. DLib is employed for face detection and facial landmark detection. It utilizes a pre-trained model to locate faces accurately and identifying the specific facial features. Then we have Telebot. This library enables interaction with the Telegram bot API, facilitating communication between the users and the system via Telegram message. Then we have Serial. The serial library is used for establishing communication with the Arduino microcontroller, allowing Python to send commands to control the relay module and electrical devices. Then we have webcam initialization. The code initializes the webcam for the video capture using the CV2.video capture circular bracket 0 function. The argument 0 is typically present to the default webcam. Telegram bot setup. The Telebot library is configured to create and manage a Telegram bot. To do this, you need to provide your unique Telegram bot API. Arduino communication. Serial communication with the Arduino microcontroller is established using serial.serial function. You will need to specify the correct serial port. Like in my case, it was COM3 and communication baud rate, which you will set. In my case, I have kept it as 9600. Now we have face detection and landmarks. The core of the code is a continuous loop that captures while frames from the webcam. Each frame is converted to grayscale using cv2.cvt color for efficient face detection. The detector object from DLib identifies the faces within the grayscale frame. If the faces are detected, the predictor object locates a specific facial landmark such as nose step. Then we have user presence and location. While the code detects the face landmarks, it can include logic to determine the user's presence and location. For instance, by analyzing the position of the nose step in relation to the screen, you can infer whether the user is on left or right side. Display information on the feed. Information such as number of faces detected can be overlaid on the video feed using CVT2.put text. This visual feedback enhances the user experience and provides real-time system status. Then we have exit condition to gracefully exit the system. The code listens to the key press event Q key. When the Q key is pressed, the loop is broken and the script proceeds to release the webcam and close all OpenCV windows. Now let's talk about the Arduino code explanation. So let's start with the pin definition. The code brings by defining the pins that control lights, or you can say any appliances. Like in my case, I have named all the relays as light. So light is considered to a specific digital pin on the Arduino. You should replace the pin number according to you. In my case, I have set my pins as 2, 3, 4, 5 with the actual pin numbers to which your lights or any appliance is connected. Then we have variables. Then we have char commands. This variable is used to store the incoming command sent via serial communication. Then we have a setup function. In the setup function, the following action is performed. The serial communication is initialized with a baud rate of 9600, allowing the Arduino to communicate with other devices such as Python. Then we have the pins connected are set as output pins using the pin mode function, indicating that they will be used to control the lights. Initially, all lights are turned off by setting their corresponding pins to high. Loop function. The loop function continuously runs in a loop and performs the following task. Checks if the incoming serial data available using serial.available. If the available data is if there is any data, it stores the variable in the variable, and based on the received command, the code takes the specific actions to control the lights or any appliances. The code interprets variable single character. Like in my case, I have did like if it receives D, it will turn off all light. If it receives, it will turn on the first light. Same for all the things. Then the digital write function is used to control the lights by setting the corresponding pin to low or high. Now let's see the live demo of this project. So here I have my complete setup. As you can see over here, I have connected my Arduino Uno with the laptop, and 4-channel relay module is already connected with the Arduino board. And over here you can see web camera is already connected with my system. And over here I have my Python code as well as Arduino code. So now I'm gonna run this. And before that, let me show you here I have my bot ready, which is named as room, and already I have started. As you can see, it is showing. Just start. Wait a minute. Yep. Now I'm gonna run it F5. Yeah, and wait a minute. Yeah. So as you can see, it has been started. It says faces at left equals to 0, and faces at right equals to 0, and equals to 0, and location is none. Let me just wait a minute. Yeah. So let me show you. Let me tell you how it works. Basically, if like person goes from left to right, then the value of a get incremented, which means someone has entered, and we will receive a message in our bot, and the basic lighting means the light one over here will get on. Okay. And if someone comes from right to left, then the value of a get decreases. If the value of a becomes 0, then it will say that do you want to turn off all the light or remain whatever is on. So if we reply yes, then it will turn off all light, or if we reply no, then it will remain the lights on. So let me show you. Now I'm gonna enter. Just wait a minute. So let me tell you. Let me show you. Like over here, it is showing that. Wait a minute. Let me show you. Like as you can see over here. Yeah, over here you can see it is written welcome to the room, basic lightings are on, you can turn on or off the custom lights. Okay, and over here you can see the lights are already on. So now if I am gonna exit the room, then we will see, then we will get to see like over here it will say do you want to turn off or on. Let me show you. Yeah, so as you can see it has started detecting my face, like was over here you can see. Now if I am gonna like go from here to here, so over here you can see that it says do you want to turn off all the lights, reply yes or no. If I reply yes, yes. So as you can see it has turned off the lights. Let me just yeah, so as you can see it turned off. Like now I will show you like turning on and off from your phone. If I say turn on light 2, as you can see the light 2 is on. Let me show you turn on light 1. As you can see it has on turn 1 and 2 as well. Let me show you turn off light 1. As you can see it has been turned off. Now I will say turn off light 2, and as you can see it has been turned off everything. Now I will show like when I will reply no, like I will re-enter, like I will go from left to right, and we will receive that message again, and we will say what will happen if I reply no to the message do you want to turn off all lights. Let me show you. So now I'm going again. So as you can see over here, it is showing welcome to the room, basic lights are on, and we have our basic lights on. Now I'm gonna exit the room and we will see what will happen if I reply no. So as you can see, I have received message, do you want to remain it on? And now I will reply no. So light will remain on, and as you can see, it didn't turn it off.